Hello, my name is John Kelly, and this is the Weber Auto YouTube channel. This is the fourth episode on the evolution of the Toyota Prius Hybrid Transaxle. As you can see, sitting beside me here is a 2017 Toyota Prius Prime. And then on the hoist, back here behind me, we have a 2017 Prius Eco. The Prius behind me on the hoist and this Prius Prime here are the fourth generation Toyota Prius here in the United States. They both use the P610 hybrid electric transaxle, and there are a few differences between the two, since the Prius Prime has an electric vehicle or EV mode only, where the Prius Eco behind me does not have much of an EV mode. So let's go take a look at this new P610 hybrid transaxle. All right, we're ready to put all the gears into the bell housing portion of the case, where we can see everything interact together with both the MG2 and the MG1 rotors and everything else. So the first thing that needs to go in here is the power split device planetary gear set, which in this big housing here contains the planet carrier that hooks to our clutch damper assembly. Now for this demonstration, I'm going to remove the planet carrier from this counter drive gear assembly so that we can have the two pieces together separately. To do that, I need to remove one of these bearings, so let me press that out real quick. Okay, so I've pressed out the bearing that's on the parking gear side of this counter drive gear housing, and now you can see down inside here is the internal gear or ring gear of the planet carrier for the power split device. The planet carrier connects to the engine through the clutch damper assembly. So that is just like the P410, just like the P112, just like the P111, just like the P510, all of the others. The power split device has not changed in all 20 years of the Prius transaxle operation. They all have the exact same number of gear teeth. They all have the exact same gear ratio on the power split device. So now the counter drive gear that has 65 teeth will slide into the bell housing side of the transmission case. This is the ring gear of our power split device. Here's our planet carrier that connects to the clutch damper assembly. There is a bearing that goes on here and a spacer, and then it just lines up with the planet gears with the internal ring gear. So the internal ring gear and the external counter drive gear are in the same housing. They turn at the same speed, but they have different number of gear teeth. All right, the next thing that would go on to our power split device, as in any other Toyota Prius transaxle, is the sun gear. So we've got the sun gear of our planetary gear set. So any planetary gear set has three components. The sun gear, which connects to our MG1 motor generator, starts the engine and also generates power to recharge the battery and to send power to MG2. We've got the planet carrier that I just installed that hooks to the internal combustion engine, or ICE. And then we have the internal gear, the ring gear here, that is connected to the same housing as our counter drive gear. So I'm going to put, and it has a bearing on it, the sun gear down into the planet carrier, and then I'm going to take our MG1 rotor and line it up and set it down into the sun gear, just like that. And then our oil pump drive shaft that turns that great big high volume pump goes down through the middle of that and connects to the planet carrier, and so this drive shaft will turn the same speed as the internal combustion engine. All right, so here is our MG1 rotor. The MG1 rotor is rated at 23 kilowatt, which is 31 horsepower. It also has 40 Newton meters of torque, or 30 foot-pound of torque maximum, and that is used. We only use that torque on the Prius Prime when we use MG1 to help propel the vehicle under certain conditions. All right, the next thing that we install is the MG2 drive gear. The MG2 drive gear here. The MG2 drive gear, of course, has MG2 stator connect to it. Now remember, these have the ball bearings and the spacers that position it in the case, and probably preload the bearings too. So we've got our spacer. I'm sure that is a selective spacer. And then our MG2 MG2 driven gear, the MG2 drives it, goes down in the case next. And of course MG2 then comes along and splines into the top of it. And MG2 is rated at 53 kilowatt, 71 horsepower, 163 Newton meters of torque, which is the same as 120 foot-pound of torque. And both of these motors have less power in the motor themselves than any of the previous Priuses out there. But what we do to get more torque out of them is to use gear reduction. Anytime you go through a gear reduction, you also get a torque multiplication. And so we end up having more torque, as I lightly explained earlier, by going through gear reduction than any of the previous Prius Transaxles. Okay, the next part that goes in is our counter-driven gear. The counter-driven gear has teeth on it right here that will spline to the MG2 driven gear and also to the MG1 power split device counter drive gear. So there's this, what I'm saying is this gear receives torque from two different locations. MG2 gives it torque, MG1 in combination with the internal combustion engine gives it torque on the regular Priuses, and then the Prius Prime, Prius Plug-In, MG1 itself can add additional torque without the internal combustion engine. So we will set that in here next. Whoops. Just like that. So now we can see on the all the previous Prius Transaxles, anytime you rotated MG2, it always rotated the ring gear or internal gear right here of the power split device. And notice now, I'll hold MG1 from rotating. If I turn MG2, this ring gear rotates. So it's exactly like the previous Transaxles, but it's just accomplished differently through this parallel axis transaxle design rather than the inline axis where we had MG2 over here on top of MG1 with another motor speed reduction planetary gear set in between them. Well, the motor speed reduction planetary gear set is out, but we still have motor speed reduction going on through the counter-driven gear, the MG2 drive gear, and the counter drive gear over here. And then, of course, our last piece to come in is our final drive assembly. Just like that. So on all previous Toyota Transaxles, if MG2 rotated at all, so did the final drive, which connects to your CV half shafts, which connect to your hub and bearing assembly and your wheels and your tires. They all turn the same speed as this. But we've got a huge gear reduction going on now here in the P610. So in order to move the vehicle forward one rotation of the tire, if you have the Prius, it's going to take 10.838 rotations of MG2 to get one rotation of the tire. And it's going to take 12.3 rotations of MG2 on the Prius Prime, Prius Plug-In to get one rotation of the tire. Now, how does that compare to just the previous model, the P410? The P410 was 8.6 rotations, but the P410 had higher horsepower, higher torque. It had 60 kilowatts instead of the 53 that we have here. And so it could handle a lower numerical gear ratio and still accelerate well. Now, since we've gone to lighter weight, smaller rotors for both MG1 and MG2, they need to spin at higher RPM to have the torque and horsepower that they need. And so they have stepped up the maximum rotational speed of both of these gears, or both of these rotors, to 17,000 RPM, which is incredible. The P410 was at 13,500. The P112 in the second generation Prius was at 10,000. And then the first generation Prius was at 6,500. But what they've done over the years since the first generation Prius is that, well, the first generation Prius had a huge rotor with a lot of torque. It was 259 pound-feet of torque, I believe, and we've only got 120 here. But it had a gear ratio that wasn't very good. It was turning like let me find it here. No, the first generation Prius took 3.9 revolutions of MG2 to get one rotation of the tire. And then the second generation went up to 4.1. And then the third generation went to 8.615. And now we're clear up to 10.8 for the Prius and 12.3 for the Prius Prime and Prius Plug-In. So faster and faster rotor speeds, less power of the rotors themselves, but through the gear reduction and torque multiplication, we actually end up with more torque at the wheels than we've had in any of the previous designs. So high-speed rotors. Now let's just go through the power flow, see how this thing transfers power in the different modes, and we will be done with this amazing P610 Transaxle. Okay, so as you're driving down the road in electric vehicle mode, with the engine off, the Planet Carrier, the internal combustion engine, is off, and there's a gear ratio from MG2 to MG1 of 1.199 or 1.2 to 1, which means MG2 will spin 1.2 turns for every 1 turn of MG1, which is kind of unusual because in the past MG1 has usually spun faster than MG2, but in this case it's not. So let me hold the input shaft from rotating. I will turn MG2 1 and a little bit more, 1.2 turns, 1 1/4 turns approximately, to get one rotation of MG1. All right. That keeps MG1 from over revving, even though we have a maximum speed of 17,000 RPM. So that means that MG2 through the counter-driven gear is driving the final drive. It's also turning MG1 and having it either generate power or just kind of sit there in a low power mode. So in electric vehicle mode now, if we want motor generator 1, like on the Prius Prime, Prius Plug-In, to help MG2 through the counter-driven gear propel the vehicle with the final drive gear here, we need to power up MG1 and have it rotate in this direction. But you'll notice if I turn MG1 in this direction, the ring gear is not moving. There's no power being transferred. And let me remove the MG1 so you can see what's going on here. I'll zoom in. Okay, so this sun gear right here is connected to MG1. So if I rotate this sun gear, that's the same as turning the MG1 rotor. So notice as I turn this sun gear, the planet carrier right below it is spinning. Now that planet carrier connects to the clutch damper, flywheel, and the engine crankshaft. Well, that just happens to be in the opposite direction. That's a reverse rotation of the engine. Well, we don't want that to happen because that doesn't allow any torque to be transferred to the final drive ring gear. We want MG1 to help MG2 propel the vehicle down the road. So if we could stop the planet carrier from rotating, so now I'm going to hold it with my finger and keep it from rotating. I'm still going to turn the sun gear. Notice now everything rotates and we are supplying power to the final drive through the MG1 rotor. So we have to stop the planetary carrier, which is hooked to our flywheel and clutch damper assembly, and that's why the Prius Prime has this one-way sprag clutch assembly. This one-way sprag clutch assembly has some spring-loaded sprags that at the higher speeds they will fling out and not be dragging like a ratchet would as you rotate a ratchet here. That ratcheting noise is little sprag teeth inside that are spring loaded, clicking on some little teeth. But if we turn it in the opposite direction, then it locks up. If we were to hold the shaft or the socket from turning, we can't turn the ratchet. That's the same idea as we're using with the flywheel and the one-way sprag. So as we start spinning MG1 in the direction we want it to spin to help propel the vehicle, that will cause the flywheel to change directions. And as it changes directions, it'll stop spinning in the one direction. It has to come to a complete stop and then start spinning the other direction. At that one point where it stops to change the directions is where those spring-loaded sprag teeth will come down and engage and lock it into place. And then MG1 can help propel the vehicle down the road. It's a neat system. Now that is not unique to Toyota. If we go clear back to the 2005 Ford Escape, it has a one-way sprag on its planet carrier. The 2017 Chrysler Pacifica minivan with the SI-EVT Transaxle has a one-way sprag on its input planet carrier. So all three, the Ford design, the Chrysler design, the Toyota design, have used this sprag method. Now, interestingly enough, the later model Fords, the second and third generation Ford Transaxles, got rid of that. And I'm not sure it was really used in the first generation one, but it's there. Now, like on any of the previous hybrid transaxles that went in the Prius or any other Toyota hybrid, we can contribute up to 100% of the engine torque to help MG2 propel the vehicle down the road. Now, how is that accomplished? It's accomplished through the power split device planetary gear set. So we've got three pieces of the planetary gear set. We've got MG1 that turns the sun gear of the planetary gear set. We've got the engine that turns the planet carrier. And then we have the internal gear or ring gear that is connected to MG2 and to the final drive. And so a neat thing about planetary gear sets is if you force any two of the three components, it doesn't matter which two, if you force any of those two components to turn the same speed, all three pieces will turn the same speed, which means there is a engine RPM for a specific vehicle speed where the MG1 rotor speed, which is the sun gear, will match the engine RPM that drives the planet carrier. Now, I did some math for this vehicle here, the 2017 Prius with the P610 transaxle. If you're driving 65 miles an hour down the road, you will get 100% engine torque with an engine RPM of 3,240. So at engine RPM of 3,240, the MG1 rotor speed is also 3,240. So that's the carrier and the sun spinning the same speed, which locks all three pieces together here on the power split device, and all of the engine torque can be transferred into the final drive, helping MG2 propel the vehicle down the road. Now, there's also another speed, engine RPM, where MG1 totally stops, and that is if you're doing the same 65 miles an hour, it's just 900 RPM lower at 2,340 RPM. So at 2,340 engine RPM, that's spinning the planet carrier at 2340. The ring gear, the internal gear, will be spinning in the opposite direction, and at that same time, MG1 just sits there. We're not electrically stopping it from rotating. It's just that that's how it works out with the planetary gear set. So kind of interesting. If it's totally stopped, obviously it's not generating any power, and that might be useful if your battery is full and you don't need additional power to help MG2 drive the vehicle down the road. You just simply turn off the generator by quit having it rotate. And then we can speed it up or slow it down faster than engine RPM or slower than engine RPM just by changing the engine RPM. So we can run it up to its maximum RPM, positive or negative, to generate current, no matter if we're in a positive or negative torque situation. Very interesting, a very neat design. And like I said, every Prius, every Toyota hybrid transaxle uses that same power split device to act as a continuously variable transmission in regard to the engine RPM. Toyota calls it an eCVT, an electronic continuously variable transmission. So MG2 has nothing to do with being continuously variable. It's a traction motor that is directly geared to the final drive. If you turn MG2, you're going to move the vehicle down the road. But the continuously variable portion, or infinitely variable, if you want to call it that, is the speed of MG1 versus the engine. All right, well, I've had a good time disassembling this transaxle and getting to know it. It's definitely different than what we're used to as far as Toyota transaxles, but I get the feeling we'll see bigger versions of this neat transaxle in the future. Thank you for watching.